Hello, welcome back. In this video, we're going to go over an exercise of related rates, and we have a moving point. And that point is on the curve y equals 1 over 1 plus x squared, and that point is moving in time on the curve. So both x and y variables depend on the third variable time. So in other words, x is a function of time as well as y is. And from this equation, or this expression here, we also know that y and x are related to each other through this. But in the meantime, x and y are functions of time. So when we take the derivatives with respect to time, these are going to be the corresponding related rates for x and y. For part A, the question is asking dy over dt, the rate of change of y with respect to time, when x equals -2, and the given quantity here is dx over dt, which is the rate of change of x with respect to time. So all we need is now to take the derivative of this expression here, but keeping in mind that y is a function of time, x is a function of time. So to achieve this goal, why don't we do the implicit differentiation? Just take the derivative of both sides of the equation with respect to time. So here we go. So we have y equals 1 over 1 plus x squared. The derivative of the left-hand side with respect to time, I'll just call it as like y prime. All right, for the right-hand side, we're going to apply the quotient rule. Essentially, what it is we take the derivative of the top, which is 0, and multiply it by the bottom. But the bottom is 1 plus x squared, and this product is going to yield 0. Minus, we keep the first, and take the derivative of the bottom. But this time, remember, we're taking the derivative of 1 plus x squared, keeping in mind that x is a function of time. And we're going to divide this by the square of the bottom. All right, so here this term is going to be 0 all the way because you're multiplying by 0. And for this one, we're going to be a little bit careful. So this is the derivative of 1 plus the derivative of x squared. But the derivative of 1 is 0. So we only take care of the derivative of x squared. Why don't we use the power rule or power rule together with the chain rule, because x squared has a derivative 2x, but since x is a function of time, we should multiply it by the chain rule. We should multiply this quantity by x prime. And this is all divided by 1 plus x squared squared. This expression is going to be used for each part of this question. But all we need to do is to make sure that we have enough ingredients to punch in here. So in part A, we have dx over dt to be given. X is known. The only thing unknown here is y and dy over dt, but y can be easily found by plugging in -2 here in the description of y, and that turns out to be 1 over 1 plus -2 quantity squared, 1 over 5. In part B, when x equals 0, it's 1 over 1 plus 0, so here the y is going to be 1. And for x equals 2, the bottom is going to be 5, so y is going to be 1 over 5. So I think we have all the ingredients for each sub-question. So for part A, plugging in -2 for x and 6 for dx over dt or x prime, and -2 for x. So the bottom is going to be 5 squared, which is 25. And the top is 24. So here y prime is going to be x equals 0, y equals 1. If x equals 0, by the way, this whole quantity is going to be 0 because the top is 0. Dividing anything would be 0, so this is 0. And then in part C, x equals 2, x prime equals 6. So 6 times 2 times 2, -24. And the bottom is going to be 1 plus 2 squared, quantity squared. So it's going to be exactly equal to 24 over 25. Okay. So from these numbers, we can just understand that in part A, Well, we have dx over dt, which is like how fast the point moves in x direction, way greater than how fast the ball moves in y direction. For part B, as you see, you move in the x direction with the velocity 6, but this is not the same for the y variable. As you see, y prime is just 0, and this is the point 0 and 1. And in part C, as you see at the point 2 and 1 over 5, dx over dt is 6, whereas dy over dt, which is the rate of change of y in time, is 24 over 25, which is way less than the velocity of the point in x direction. All right, this is the end of the video. I'll see you in another video. Bye.